Go to modules. All right, ladies and gents, when you combine functions, what are you doing? What do I mean by combining? You're putting them together. All right, we're just putting them together. We're going to add, we're going to subtract, we're going to multiply, and we're going to divide. And we're going to talk about domain restrictions. We've talked about this a bunch. What are the 3 rules that we have to remember about our domain? What's in the denominator? Variable in the square root. Okay, what else? Okay, variable under square root. And what else? Under square root in a denominator, okay? We have to, those rules are never going to go away. We have to remember them. So when I look at this, look at my f function. If I have just the f function, just by itself, f of x equals 3 minus x squared, do I have any domain restrictions? No. Negative infinity, positive infinity. I can plug in anything I want, correct? Okay. All right, what about with g? Do we have a problem? Yes. What's the problem? All right, so how do I fix that? If I was going to state the domain of just the g function by itself, what's the problem? Not greater than. Can it equal 0? No, your denominator cannot equal. So we have to say x squared minus 4 cannot be what number? 0. We need to find out what will make my denominator 0. Question? What if we did? Or we can just solve. If I move 4 to the other side, I have x squared cannot be 4. Yeah? Take the what?
It's the square root.
I'm going to take the square root. So x cannot be what 2 numbers? Plus or minus 2. Any number in the world but plus or minus 2, because if I plug in positive 2 or negative 2, my denominator becomes 0. Now, if we were going to write our domain just from here, some of you can do that. Some of you are still having problems with that. So I told you a good way to kind of see it visually is to draw a number line. I have negative 2 and positive 2, correct? What kind of circles would I have at positive and negative 2? I'd have them both open because it does not include, correct? So I can use everything over here. I can use everything over here and everything where else? In between those two. So how can I write that? How can I write I can use everything in the world except for? Negative infinity to negative 2. Agreed.
Union.
Uh-huh.
Negative 2.
Uh-huh.
Union.
Whoops.
To positive infinity.
2 to infinity. Good. Questions?
Oh, we don't equal anything to 0. What about this? Or not equal.
What about the 0?
Like I thought it was.
Hold on. I'm sorry, Clay. I'm answering Sam. Hang on.
Oh, you're fine.
No, you're fine.
Like, wouldn't we have to, like, because it's not included?
0 is included. 0 works.
It's just like have the denominator.
I was just giving you a reference point of where negative 2 was and where positive 2 was. If you plug in 0, think about it, Sam. If you plug in 0 here, what's 0 squared? 0. And the 0 minus 4 is negative 4. So you are right.
Wait, so what's the answer to the first?
Well, I'm just talking about, I just want you guys to talk about domain for a second. We're just talking about what we can and can't have. If I add these two functions together, right, I'm going to add f of g, f of x, and g of x, correct? That's what this says. So if you take the f function, 3 minus x squared, and add it to the g function, x squared minus 4, can I combine anything? Do I have any like terms? I do have x squares, but one's in a numerator, one's in a denominator, correct? Yeah. All right, we can leave this over 1. You guys could leave it like this. If you did get a common denominator, what would a
We can just leave it like that? We don't have to multiply?
Hold on, Connor, just give me a second. If we were to get a common denominator, what would your common denominator be? X squared minus 4, okay? So x squared minus 4. Your first fraction, 3 minus x squared. We have to multiply by x squared minus 4, correct? My second fraction, do I have to multiply by anything?
No.
Are my denominators the same if I just leave them like that?
No, they cross out.
No, they don't cross out. Are they the same?
They're not.
No,
You have to
like, you
change the
multiply.
top one.
What would I have to multiply by?
The x squared minus 4.
It already has an x squared minus 4.
Oh, they're trying to put them on the left.
Yeah, the one on the left. Yeah, so if we multiply, 3 times x squared is 3x squared. 3 times negative 4, give me negative what? 12. All right. Negative x squared and x squared is negative x to the fourth, and then negative x squared, negative 4,
Positive 4 squared.
positive 4x squared. And can we combine?
Yeah.
What do we do?
7x squared.
I agree. What goes first, though?
Negative x to the fourth.
Negative x to the fourth. Then what?
And then positive 7x squared.
Plus 7x squared
Minus 12.
minus 12 over x squared minus 4. Everything that you guys have talked about before, getting a common denominator, we've talked about rationals, we've talked about domain restrictions, all that kind of stuff. It all goes into this. It's just kind of working all of it together. Just take it step by step, Zach. Let's look at another one. Let's go down here if we multiply. Let's talk about multiplying these two functions together. What if we multiply? We're going to take our two functions and we're multiplying them together. So it's 3 minus x squared, correct? Yeah. And then I have 1 over x squared minus 4, yes? Okay. Can I multiply these two together? Yeah.
Just plop the 3 minus x squared on top of what we have right here.
How come I can't just cross off the x squareds? I agree, you can't, but why, do you know why?
No, because it's being subtracted and added, it's not being multiplied.
Correct, very good, very good.
Not their own individual.
Do we have domain issues?
Yes, it's going to be the same domain as what we talked about earlier.
How come?
Because we have the same x squared minus 4.
In the denominator. Can I put anything I want in my numerator?
No. Oh, like the
Yeah.
plug-in?
Yeah. What happens if I plug in a negative number? What happens when you square a negative number? It becomes positive, just becomes a number. What if we plug in 0?
That's fine.
Okay, we're fine. What about if we plug in a negative number? We're good. Our problem, the rule that we're breaking, again, is our denominator. We have a variable in the denominator, so we have to find out what number or numbers will make our denominator become 0. Right? Negative 2, positive 2. What about if we divide these two functions? How would I write it? Tell me first how to write it.
3 minus x squared.
Okay, 3 minus x squared
Over 1 over x squared minus 4.
Wait.
We're taking the two functions from the beginning, and we're dividing them, right? I just wrote one on top of the other.
Are we divided?
Yes.
Oh, yeah, okay.
Just flip it. That's all you need.
Okay, hang on. How do we divide fractions? You keep, change, flip. So I keep 3 minus x squared, yeah? Then what happens? Times x squared minus 4. Can I combine? What do I do? Okay, so 3 times x squared is 3x squared. 3 times negative 4 is negative x squared, and x squared is negative x to the fourth. And negative x squared, negative 4 is?
Negative 4 plus squared.
Negative times negative is a positive. Can I just leave my answer like this? Why not? There's 2 reasons why I can't. It's not in standard form, and we didn't what? Combine like terms or simplify. Okay, so what would come first? Negative x to the fourth. Good, then what?
Plus 3x.
Wait, where did you get negative? Plus
Should be,
The x
plus
squared.
4x.
yes, thank you. Yeah, this should be 4x squared, right? Instead of putting the squared, I multiplied the 4 and 2. All right, so we have negative x to the fourth. What happens with my 3x squared and my 4x squared? Becomes 7x squared, and then what? Minus 12. Guys, do I have any domain restrictions here?
No. So
Why not?
Because there's nothing in the denominator.
I'm not breaking any of the rules, am I? So my domain here would be negative infinity to positive infinity. So when you are leaving things in terms of x, hold on one sec. When you're leaving things in terms of x, you guys have to make sure you have x's in your answer. If it has a number to plug in, which I'll show you in a second, then you would actually have a number as an answer. Yes, ma'am. Our domain restrictions are 1, if there's a variable in a denominator, right, you have to set the denominator not equal to 0. If you have a variable underneath a square root, you have to set the square root expression greater than or equal to 0. Or if you have a variable in a denominator underneath a square root, then you have to set that expression greater than 0. Let's look at these. Look at this one. All right, this problem is really, really simple if you know what it's saying. It's saying F is a composition of F. Where did I tell you to work? How did I tell you to work these problems out? Inside out. So the first thing I'm going to do is plug in what number into what function. So I have 4 times 2 minus 2. Agreed? Okay. What is 4 times 2? 8. And 8 minus 2 is 6. So what you just figured out was when I plug 2 into the F function, I get a 6 out. Correct? All right. Now, what am I supposed to do? Take the 6 and plug it into what function? The F again, okay? So I have 4 times 6 minus 2. What is 4 times 6? 24 minus 2 is 22. So F of 2 equals 22. We work from the inside out. How did you know that your answer should have been a numerical answer? Because there's a number right here that's telling you to evaluate with. Do you guys see that? Does that make sense? All right, so if I look at the next one, what is the first thing I need to do? Plug 3 into what function? To the G. So 5 minus 3 squared. What do I do first? The 3 squared. So I have 5 minus 9 equals what? Negative 4, okay? So I just figured out that G of 3 is negative 4. So now what do? I take that negative 4 and I plug it into what? To the G function again. So I have 5 minus negative 4 squared. What is negative 4 squared? 16. So 5 minus 16 gives me negative 11. So G of 3 equals negative 11. All I need to see is the negative 11 part. Excuse me. Yeah. It's a little more difficult when there's x's involved. I understand that. All right, let's look at the next one. How is this one different from what we just did above? It's the same thing. It's just written differently. That doesn't say fog. It doesn't say F times G. This is the same thing as saying F of G of negative 2. Work how? How do you work? Inside out. So I'm going to take this right here and I do what? Plug in negative 2 to what function? To the G. So I have 5 minus negative 2 squared. Everybody with me? Okay, so what is negative 2 squared? 4. And 5 minus 4 is? What kind of 1? Positive 1, okay. Now what do I do with that 1? Plug it into the F. So I'm going to say, okay, 4 times 1 minus 2. Well, what's 4 times 1? 4. And 4 minus 2 is? 2. So my answer here is 2. Work from the inside out. Good. Inside out. We're going to work from the inside out. So I'm going to do what? What is this telling me to do? Plug in negative 2 where? To the F function. So 4 times negative 2 minus 2. What is 4 times negative 2? And negative 8 minus 2 is? Negative 10. All right. Now what? Take that and plug it into the G. So I have 5 minus negative 10 squared. What is negative 10 squared? 100. So 5 minus 100 gives me negative 95. Good, guys. Very good. All right, moving along here. How is this a little bit different from what we just did? There's a variable. There's an x. So what should I have in my answer? An x. So in this first one, they're telling me take the g function. So take g and plug it in right there. Agreed? Okay. So 4 times 5 minus x squared, correct? Minus 2. I took the entire g function and put it right in there for the x value. And then how do we simplify? You just distribute and then combine like terms. So 4 times 5 is 20 minus 4 times x squared is 4x squared minus 2, right? What can I combine? The 20 and the negative 2. So this would be negative 4x squared plus 18. Yeah? Okay, good. Now the second one, it's using the same letters, the same functions, but am I going to get the same answer? Why not? We're doing something different. We're taking this f function, and I'm going to plug it right in there where the g is. Just be careful, or where the x is in the g function. So I have 5 minus, instead of x, I'm going to have 4x minus 2, and then what do I have to finish it off with? The squared part. Good. So as we go through to simplify, guys, 5 minus, I have 4x minus 2 times 4x minus 2. Everybody agreed? Leave that 5 minus out in front. Don't do anything with it. Leave it out in front. I'm just going to rewrite it as 5 minus. Now I'm going to worry about foiling. What is 4x times 4x? 16x squared. What is 4x times negative 2? Negative 8x. What is negative 2 times 4x? Negative 8x. Good. And then what's a negative 2 and a negative 2? Plus 4. Plus 4. Now leave that 5 minus out in front. Don't do anything with it yet. Let's clean up in the middle. I have 16x squared. What's negative 8 and negative 8? Minus 16x, then what? Plus 4, good. Now, what's going on? I have to distribute that negative. There's a little 1 right there. When you distribute that negative, what's going to happen to all the signs? They're all going to change. So this becomes 5 minus 16x squared, right? 2 negatives gives me a positive 16x. And then a what? Minus 4. Now, how can I write this as completely as possible? Negative 16x squared. Everything needs to be in standard form. Then what? Plus 16x plus 1. Perfect. On Friday. Yes? Inverses? What did we talk about with our domain and range? When we had domain and range values, our x's and our y's, and inverses, what happens to them? They switch, right? We're going to talk about graphing later on, probably at the end of chapter 3. We'll do it after Christmas. We're going to actually do some more graphing stuff. But right now we're finding inverses algebraically. If they give you a question that says find the inverse of, that means that there is an inverse. There's one that exists. So if I look at this question, and again, this is different than you guys had on your web assign. How do I go about solving this algebraically? Okay, change our f of x. We're going to change it to the letter y. Good, because f of x is just a fancy way of saying y. Good. Switch the places of the x and the y. So I have x equals 7y squared plus 6. Everybody with me? Talk to me. I want to isolate y. Look, I'm trying to get y, different color. Y all by itself. What's my first step? I'm going to subtract 6 from both sides. Good. So we have x minus 6 equals 7y squared. Now what? Good. Divide by 7. Alyssa, is that you over there? Yeah. What? I like it. So x minus 6 divided by 7 equals y squared. Is y all by itself? No. What do I need to do? I'm going to take the square root. Guys, if I take the square root, there we go. Now, to get full credit full credit, Mrs. Meadows, this is the inverse of my function. What does it need to start off with? F -1. You need to use your inverse notation. Make sure that little -1 is little. It's not like timesing by -1 or anything. And then we can write. Make sure that your whole function is underneath your square root. Here you go, Avril. All right, what's my first step? Zach, tell me what to do. You got it. Okay, flip the x and the y. So I have x equals, I have 7 minus 5y cubed, right? Divided by 4. All right. We're going to undo. I want to get y all by itself. So what's the first thing I'm going to do? Perfect. We're going to multiply both sides by 4. So we have 4x equals 7 minus 5y cubed. Again, we're trying to isolate. If it helps you guys, keep highlighting y. You want to get y all by itself. So what's my next step? What am I going to do? Subtract 7. Perfect. So I have 4x minus 7 equals what? Negative 5y cubed. Good. Perfect. Divide both sides by -5. I'm just switching y on the, I just like it better like that. So I have 4x minus 7 over -5. Yeah? And now we take the cube root. How do I write this correctly? F -1 of x. My inverse is the cube root of 4x minus 7 divided by -5. Now here, Avril, is why you have to have the little number, because it's not the square root. If there's no number there, you just assume it's 2. But since we're taking the cube root, you have to write the index of 3. If it was to the 5th power, you would take the 5th root. Does that make sense?
So you don't put a plus or minus because it's not.
Because it's an odd root, right? Your answer can't be either odd or, positive or negative. Alyssa, question, or are you good? Here we go again. They're telling you a function, giving you the function. They're telling you the inverse exists where all of the x values are greater than or equal to 6. So the first thing I'm going to do to solve is switch what? Switch the x and the y. So x equals 6 plus the square root of 2 plus y, correct? All right, I'm trying to isolate y. Subtract, say it again? 6, good, subtract 6. Now pay attention to this one, guys. X minus 6 equals the square root of 2 plus y. I need to get y all by itself. Do I just subtract 2? I have to square both sides. Now, when I square both sides, what happens with x minus 6? The entire expression is squared. It's not just 6 is squared. I don't put x on, I don't put the squared on the x and the 6. It's the entire expression, x minus 6, squared. Everybody see that? All right, so this cancels out. So I have x minus 6 squared equals 2 plus y. And then what?
Subtract 2.
I'm going to subtract 2. Do I subtract 2 from the 6? No. That expression, x minus 6, is in parentheses. By itself, it's staying together. We square it, and then the minus 2 is on the end. So to write this correctly in your most wonderful fashion, you have to tell me, Miss Meadows, this is my inverse. If you guys do not write your inverse notation, I'm going to take points off. But we have x minus 6 squared. No, plus it. Yeah, x minus 6 squared minus 2. All right, let's look at the last one. Our inverse exists in between the values of 0 and 6 on our x-axis, but how do I solve this algebraically? Alyssa, you want to do it? Tell me the first step. You know. You've been telling me the whole time.
Yeah, I know, but now it's like
Inverse. What do we do with our x and y?
Okay, so you cross out the x and change y.
Okay, so I have x equals, and we're going to say the square root of 36 minus y squared. Yeah? Chloe. Oh, now you want to...
A little bit.
Okay.
I'm gonna go till I get it wrong.
The only reason I said that is because Chloe just asked this question, but go ahead.
Oh, if you want to go.
No, it's fine.
Then, you square.
Okay, we're gonna what?
Um,
It's already square rooted, so it's the opposite of taking the square root. You're gonna square both sides. I knew that's what you meant. I knew you're fine. That's fine. So I have x squared equals 36 minus y squared. Yeah? All right, we're still trying to get y all by itself.
subtract 36.
Okay, subtract 36. So x squared minus 36 equals negative y squared. What's the problem there? Good, Zach. We're going to divide by negative 1. Good. When I divide by negative, what happens to signs?
Oh, this changed.
Yeah, good. So my negative x squared, negative divided by negative is a good. Yep.
Plus or minus.
Good. So write it as correctly as possible. Whoops. You guys can all do this. You just have to take your time.
No, see, if you just
Look at me. Look at me.
through it.
You can talk yourself through it.
No, if you were
Yes, you
in
can.
the test, you were just.
Uh-huh. Talk about stuff that's on the test tomorrow, okay? So you guys are aware. There's 15 questions. Don't look at me with those big... You guys are going to be all right. There's 15 questions. We have average rate of change, which if you're given an x value and you have a graph, how do you find out what values to use for y? You look at the y. Good. And then you figure out the rate of change. You guys can all handle that. How do we figure out transformations when we're given equations? We got to see what's going on, right? If I have a negative sign out in front of my function. Ooh, look at you. Good job. If I have a negative sign inside. Good. Very good. Where does our vertical stretch and shrink occur? Very good. Yes, we have to know this. This was on your...
No, I knew it for the last test. But
Yes, math is cumulative. Guess what? You're going to have this on your midterm when you guys have it. How do I know if something's moving up or down? In the back. All right, good. So you're going to have a couple, guys, where you're given the equation and you have to name the transformations, just like you did on your quiz. Algebraically, figuring out odd, even, neither. All right. How do I even start that problem? How do I figure out, oh my gosh, I don't know if it's odd or even. You look at your highest exponent, right? And then we have to think about if my function is even when I work it out algebraically, the answers I get should be the same. If I think my function is odd when I work it out algebraically, my answer should be opposite. And if it's neither, they don't have anything to do with each other. Correct? Yes, ma'am.
About the transformations, is there going to be one like
All right, you're going to have combining and composition of functions. Or like 5 or 6 of those. And then 2 inverses. It's very comprehensive, all right? It's probably going to take you guys a majority of the... Hold on one second. It's probably going to make a majority of the class period. This is not going to be something that you just sit down and just whip through. You guys are prepared for it, is what I want you to understand. Like, there's no reason to go in, unless you haven't been paying attention, then that's on you. But you guys, you can do this. The concepts are going to keep getting a little more difficult, but you guys are doing a good job, so just stay on top of it. Avril.